Jonathan Hurst, co-founder of U.S. humanoid robotics pioneer Agility Robotics, just wrapped up a quick but important visit to Taiwan. He met with optical manufacturer Ability to explore new partnerships and held his first media briefing here, sharing how Taiwan could power the next wave of humanoid robots.
And I know that some are imagining that humanoid robots will first be deployed in the home. But I don't believe that to be true. I believe it will be more than 10 years before humanoid robots will be safely deployed in the home. And if you think about even very simple in-home robots like Roomba, the robot vacuum cleaner, they had a major challenge to have a reliable and low-cost sensor that would prevent these robots from falling down the stairs. Because you can imagine a child at the bottom of the stairs, even a small robot vacuum cleaner falling down could seriously injure them. A humanoid robot is so much more risky and potentially dangerous than a small robot vacuum. Any robot that has the strength to lift a 25-kilogram bin or tote has the strength to accidentally injure somebody.
Agility is the world's first humanoid robot unicorn, joining Tesla, Boston Dynamics, and Figure at the top of the field. Even NVIDIA joined its Series C round, reportedly investing up to $30 million. Taiwan's Abaco Asia and Ability have also put in about 300 million Taiwan dollars. Hurst says this isn't just cash. Ability's imaging expertise boosts robotic vision and helps build a supply chain for sensors, actuators, and more. He points to Taiwan's strength in camera modules, processors, motors, and gearboxes, all critical for humanoid robots.
But in logistics, we can control it. It's a very regulated environment. We know what the safety environment looks like. We know how to make these things operate safely around people. And gradually, as we have the hours of these robots out in the factory, and we know how often they will fall, and we know the redundant actuators and redundant sensors and can certify these systems and understand how reliable they are, now we can have people be closer and closer and closer to them. Eventually the robots will be able to touch somebody, but imagine the intelligence that the robot has to have to never touch you in the eye and only touch you on the shoulder. There's even social rules about this. It's very difficult. So to start with, I see this in the warehouses, moving bins and totes, and then moving boxes, and doing things like unloading tractor trailers, and sorting boxes and mail on conveyors, and then working in manufacturing with much more complex devices, and then doing assembly tasks, and then installing wire harnesses in vehicles and cars. That's a much, much more difficult manipulation task, but it's something that a robot that moves more like a person will be able to do. And then into grocery and retail, once the safety is there. You can imagine they start in the back rooms, unpacking boxes and so on, and then working at night when customers are not in the store. And then eventually, maybe they just close off an aisle while the robot is doing stocking for the aisle. And then eventually, the robots will be able to operate with people walking by. Maybe he has to just stop moving and hold still, but not fall over. And you can imagine this progression of improved safety and capabilities until these robots have the safe intelligence enough to be able to touch a person with as much trust as another human being. But it will take a while to get out to that level of trust and intelligence that is that safe. And that's when we're going to have robots operating in commercial environments during the daytime when we are there with them, in hospitals, in our homes, and so on. So the question is, looking at the development of humanoid robots right now, and how exciting it is to see so many companies in China in particular, but also in the United States and the rest of the world, beginning to show the technology and its possibilities. I have seen some very impressive demonstrations of this technology from Chinese companies. I have not seen the same level of product focus and product design yet. So our focus, think of it this way, you don't necessarily think of internet companies anymore, but when the internet first came out, they were internet companies. Now you think about robotics companies or humanoid companies, but in the future, they'll just be companies that are providing a service or a product. Humanoid is more like a technology choice. It's not a product. There will be different humanoids that can do different things. A humanoid that operates in the home will be different from a humanoid that operates in a factory. It might be a bit like cars. A truck is different from a sports car. And there are many big automotive manufacturers, each of which have their own strategy, their own path. That's how I see the humanoid market grow as well. There will be many major humanoid robot manufacturers, and each one of them will have their own strategy in a particular part of the market where they are strongest, and will continue to grow and evolve. So another thing I will point out is that Chinese companies will have a difficult time gaining trust in Western markets. Right now, the political climate is not friendly to Chinese companies entering the United States and Western markets. So that certainly leaves an opportunity to be serving all of Europe and the United States, and then more broadly internationally. It will be about product design. Many humanoids are very, very different from one another. So remember, Digit can lift 25 kilograms and has functional safety built in, and has a very fast charging battery and self-charges, and can do 20 hours of work in a 24-hour day. Unitree is an example of a Chinese company that's been very successful and shown some very impressive technologies. But the robot is only about this tall. It cannot lift 25 kilogram totes. It does not have the battery life. It does not have functional safety. It does not have the set of sensors. It's not a product designed to do the same thing that our robot is designed to do. So while they are similar in that they both look a little bit like a person, they're very different in that they're very, very different products with very different strategies. Think about the difference between how an industrial robot arm moves and how an animal moves. An industrial robot arm, like a CNC machine, is a position control device. It follows a trajectory with very high precision, and that precision is on its position. But if an industrial arm unexpectedly runs into some hard object, it will be bad. Things will break. The robot arm will break, the thing that it runs into will break. The forces are very, very high. But people and animals run into things unexpectedly all the time. You use the environment, like the surface of the table. Maybe I don't know where it is, but I can put my hand on the table and slide it until I make contact with the water bottle. I can feel it, and I am compliant, like a spring. I'm soft when I make these connections with the world. That's very important. That compliant, soft interaction with the world is what allows us to be very, very good at assembly and so many manipulation tasks, and walking and running. We are not very good at some of the things robot arms are. We're not very good at high position precision. We're not very good at machining aluminum by hand. That's okay, we have robots for that. But if we want our robots, humanoid robots, to exist in human spaces, now we need an actuator technology that is new and different, that can handle regular impacts with the ground over and over and over durably, that can have a compliant interaction with the world, that can control the forces that they're applying. So starting with that foundation is very important, and building a hardware system that is even physically capable, just based on physics, the inertias, the friction of the hardware, the physical hardware, to make it possible for the AI approaches to control these robots to do the useful things in the world. This is a new and growing technology, and it's just something that 10 years ago, it was a very small community, very few people studying it and understanding it. Now we're seeing a lot of people pay attention to it as they run into these problems, like you read about Tesla. So the world is figuring it out, and we will have a lot of new innovation and novel technology and actuators, but I believe Agility Robotics is significantly ahead. Our transmissions are, for our purposes, better than any in the world for how well they operate and what their properties are. Like I said, though, end of next year is when Digit V5 will be released, end of 2026, and that is the scaling moment. Those are the robots that do not need a work cell, that can just operate without any additional infrastructure, and that's the point. They've already shown that they can do the work. They've already shown that they provide a return on investment and provide value for the customers. The blocker right now is safety environment. So once we are able to solve that and Digit V5 is released, that's the scaling moment. And I guess one more point about that. The safety features are holistic through every aspect of the robot. You cannot take an existing robot and then add safety to it. Our robot had to be designed from the ground up with the customer requirements, including safety. It affects the way the data bus is done. It affects our power electronics, having gone through a certification process. It affects even the shape of the legs and the body, so that the robot will fall a certain way that we understand and is reliable. It affects where we locate the sensor array all around the robot. So every feature of the robot requires having an understanding of that safety environment and the safety strategy before it can be a successful product that can expand outside of the work cell. So every other company that wants to be outside of a work cell is going to have to redesign their robots from the ground up in order to be able to achieve this. And Agility Robotics is fortunate that we were the first to deploy these robots and to do the proofs of concept early so that we could learn these things and begin that process sooner. Like I say, we have the capacity to build up to 10,000 robots in this factory. We are just about at the scaling moment for our robots. So right now we have tens of robots, not very many, that are deployed commercially. And the primary reason for that is safety. When you deploy a robot or any piece of automation in a warehouse, certainly in the United States, the insurance companies have to understand what risk they're taking. And they are going to rely on TÜV Rheinland and other third-party certification bodies to be able to certify that you are following all regulatory environment and are producing a safe product. There is no regulatory environment around dynamically stable balancing robots. So that means that we have to invent from the very ground up the safety strategy for these robots and how they will be safe. And we have to then go through the self-certification process. It's very involved. We've determined in order to make a balancing, dynamically stable robot safe, they have to be able to detect a person. And no automation system does that right now. They detect obstacles. So like an AMR will roll up, and if it is a person or a box or a wall, the robot doesn't know the difference, but it doesn't matter because it needs to stop and slow down. However, Digit needs to touch lots of things. It needs to pick up the boxes. So it has to treat, but it is not allowed to touch a person. So Digit has to understand the difference between a person and a statue of the same person. So we have the complete sensor array on the robot that through AI approaches are certifiably able to detect people. And then that means when a person is approaching the robot, it can stop moving and sit down on the ground before the person can touch it, so that the robot would not be able to fall on your foot or land on your leg or have a pinch point when the robot moves a joint and your hand is near the joint. The robot would not be able to move when the person did. Now, today, any company anywhere that needs to deploy a humanoid robot or any dynamically stable robot in a warehouse, they have to build a cage around the robot. They have to have a physical barrier, a work cell, so that people cannot be in the same space. But you can imagine a humanoid robot is not very useful if it has to be inside of a work cell. That means we have to install all the infrastructure. And you might as well just use traditional automation. So once we deploy late next year, Digit version 5, which will have functional safety throughout, and will have the self-certification process, and is the beginning of an ISO standard for how to deploy dynamically stable humanoid robots, that is the point at which we can start selling them in the hundreds and the thousands, and we start to scale up our manufacturing volume.